Hello guys, let we see in these video parts to know about artificial intelligence. Take your own separate notes, first understand the concept and after that what you understand about these and fulfill the notes in your own understandable way. Depth First Search, DFS, is an algorithm used in artificial intelligence and computer science to traverse or search tree or graph data structures. It starts at the root node and explores as far as possible along each branch before backtracking. It traverses the depth of any particular branch before moving to the next branch. Depth-first search has several advantages. 1. Simplicity. It is relatively easy to implement and understand compared to other search algorithms. 2. Memory efficiency. DFS uses less memory because it does not need to store all the nodes in memory like breadth-first search, BFS, does. It only needs to store the path from the root to the current node. 3. Space efficiency. It requires less space compared to BFS because it does not need to store all the nodes at each level before moving to the next level. 4. Completeness. DFS is complete for finite state spaces, meaning it will find a solution if one exists. 5. Applicability. DFS is useful in situations where finding any solution is more important than finding the optimal solution. It's often used in problems like maze solving, topological sorting, and finding connected components in graphs. One disadvantage of depth-first search, DFS, is 1. Completeness in infinite spaces. DFS may get stuck in an infinite loop if the search space is infinite, or if the search encounters cycles in graphs. Without proper precautions, it might continue exploring infinitely without finding a solution. Additionally, DFS might not always find the optimal solution in problems where the optimal solution is not necessarily the deepest one. This is because DFS prioritizes depth over breadth, potentially missing shorter paths to the solution. Furthermore, DFS can be inefficient in very deep or branching trees, as it might explore a large portion of the tree before finding a solution, leading to wasted computation. Applications of depth-first search, DFS. 1. Graph traversal. DFS is commonly used to traverse graphs and find connected components, cycles, or paths between nodes. 2. Game playing. In game playing algorithms like Minimax, with alpha-beta pruning, DFS can be used to search through the game tree to find the best move. 3. Network analysis. DFS can be applied in network analysis to explore social networks, web graphs, or computer networks, such as finding the shortest path between two nodes or detecting communities. 4. Puzzle solving. DFS can be used to solve puzzles such as Sudoku, N-Queens, or the 8 puzzle by searching through possible states and backtracking when a dead end is reached. 5. Syntax analysis. In compilers, DFS is used in syntax analysis, parsing, to traverse the abstract syntax tree, AST, generated from the source code. 6. Artificial intelligence. DFS is utilized in various AI applications, such as constraint satisfaction problems, where it explores possible assignments until a solution is found. These are just a few examples of how DFS is used in different domains to solve various problems efficiently. Here we go to see. Take a graph like showing on the screen. Graph explanation. Take a root node S, then S to pass nodes A and H. A to passing nodes B and C, H to passing nodes I and J, B to passing nodes D and E, C to passing node G. G is a goal node. I to passing node K. Then graph represents to show levels. S is a level 0. A and H is a level 1. B C I J I S a level 2. D E G K I S level 3. From graph.
Procedure to solve depth first search. Continued arrows from S to D, after that from D they have to pass to B and B pass to E. These process called as backtracking way, after that E can't have more passing nodes from E to travel. So simply E will be travels to C and C will be in same way to travel to G. Then G is a goal node. Completeness. Its is a complete within finite state space. Time complexity. T of nu class to 1 plus n square plus n cube plus going on. Plus n to the power of p of nu class to 0 of n to the power of m equals maximum depth of any node.